Hello all. In this video, we'll talk about data structures. So, what is mean by a data structure? First, we will talk about what the definition of data structure. We will understand more about it, and later we will go into the different kinds of data structures that are predominantly used. Now, now we'll talk about the data structure definition. So before going into that, let's consider in a class there are 10 students present in a class, and let's say their roll numbers are from 1 to 10. Okay, this is a data, right? Data is nothing but a information, be it anything, be it the student details or item details or books details, anything. Data can be anything which stores the information. Now let's consider that there are 10 students present in a class. Now, instead of remembering by ourselves in our mind, instead of storing that in our mind, you store it in a digitally, right? Like you store it in a computer. Let's say I want to store this 1 to 10 students details in a computer memory. Now, how you will store in a computer? You can store it anyway. Like coming to the storage, you can store it anyway. Like you can store it in contiguous locations. What do you mean by contiguous locations? Means you store all 10 persons details together, like adjacent to each other. First student details are stored, next you store a second person details adjacent to the first one, and next three, next four, like this is nothing but a contiguous storage. Okay, now you can store it in a contiguous locations, or you can store it in you can store it randomly in a computer memory. You can store it anyway. Now let's say you have stored first 10% details in the computer. Now let's say a person comes, or a parent or some other person comes, and they want to know the eighth person details. Now I should go to the computer memory and search for eighth person details and give it. So here comes the retrieval part. Fetch details from computer memory, right? Now, in addition to this, what else operations can be done on this data? Now, a new student has joined in that class. Then what I need to do? I have to add the student details along. Let's say a new student had joined. Now I will add 11th person details. Okay, now add it to the current add the new student details. Okay, this is that. Now let's say a person has moved, like he has shifted from one school to the another school. Let's say the fifth person has shifted. Now you need not store the fifth person details, you should remove it. Removal should happen, right? Adding, removal, and there are lots of operations that can happen on this. Maybe you will sort the student details by height, or you might sort the student details based on the date they have joined. There are multiple operations that can happen on a data, right? So data structure is because there can be multiple operations: storage, retrieval, adding, removal. Likewise, there can be multiple operations that can happen on your data. So data structure is nothing but how you organize your data, right? So you can, like as I was saying, you can store it contiguously or randomly, right? How you organize your data so that you will perform all these operations: storage, retrieval, adding, or removal. There can be, like let's say I can store these 1 to 11 details in an array, or I can store it in a linked list, or might be I can store it in some other data structure like a stack. So it depends on your use case how you store your data. So data structure is nothing but storing your data or organizing your data based on your requirement in a computer memory. So this is what data structure. It's nothing but how you structure your data. The name itself gives you the explanation of the data structure, how you structure your data. So this is nothing but the data structure. Basically, you organize your data in a computer memory, and later on you can perform few operations on the data like retrieval, adding, removal. Okay. So it depends on your use case how you store it. So coming to the types of data structures, there are if you categorize, there are so many data structures present, but out of those data structures, those are categorized into two types as shown in this particular diagram: linear and non-linear data structures. Okay, now we'll go into linear and non-linear data structure. What is mean by a linear and non-linear data structure? Okay, now, if you remember in our school days, you would have heard about linear equation or non-linear equation in mathematical graph, right? A linear equation is nothing but, let's say you have multiple points on a graph, okay? Now, you plot your points on the graph, or let's say I have some data like A, B, C, D, something like that. Now, if you join all these points via a straight line, like let's say I join all these points, if after joining, if all these points lies on a straight line, then you call that as a linear, right? If all the points doesn't form a straight line, might be if it forms like a curve or some other shape, then you call that as a non-linear. It is in general terms. Okay, now coming to data structure, what is linear data structure and non-linear data structure? Let's say there are so many data structures like array, linked list, and stack. So if you see how data is organized in these data structures, let's say if you take an array data structure. So this is an array data structure. This is how data is stored in computer memory. Like if you heard about, like if you if you think in terms of computer memory, each like each location has some memory address, right? Each location has some address, like let's say I am from Delhi, then I'm staying in a particular house. Then what is like I'll have my home address. Likewise, other people also, you have some address. In the same way, even in the computer, each location or each space will have a memory address. Okay, so as I was telling, let's take, there are 12 students present in the class, and I'm storing just roll numbers of those students. Roll numbers are nothing but integer data type. Let's say an integer data type occupies 2 bytes of memory. It takes 2 bytes of memory. Now, I take the first location in a computer memory, 0. I start from 0. Then I store first student roll number. Now it occupies 2 bytes of memory, right? So 0, 1. 0th memory and first memory are allocated to the first student. Then from third, like 0 1, like 1 0 1 2, then if you take from the third location, second student details are stored. Second student roll number is 2, but since we are using integer data type, it takes 2 bytes, right? So I store it at the third location. If you take the third person, then it is stored at the fifth location. 3 plus 2 5, 5 plus 2 7. At the seventh address, I store the fourth details. If you see, all these details are stored continuously. It's not that I store like let's say first 4 details are stored till 7th memory location and the remaining are stored somewhere from 19. It's not like that. Those are stored contiguous memory locations. So this is how you represent an array. Now, let's talk about linked list. Okay, if you see, like first we will talk about how we store data, how we represent array or linked list or stack or queue in the memory. Then we will talk about the differences between the linear and non-linear. Now we spoke how the data is stored in the array, right? Let's talk about linked list. If you see a linked list, it's not stored in contiguous locations, okay? Because if you think about array, let's say if I want to store 12 people details, I need to, in the computer, I need to have a memory sufficient for those 12 people contiguous location. Let's say at 0th location I have some memory, and at the 50th location I have some memory. but it's not useful for an array because array has to be represented in a contiguous locations. But if you come to the linked list, it's not like that. Like even if you have 4 bytes of memory at one place and 4 bytes of memory at some other random place, then we can go for linked list. If you see here the linked list, how it stores is it stores 10 data. Like this is the data. Consider this as a roll number. Let's say 10th roll number is stored. Now next student roll number is stored at the 39th memory. This is the memory location. This 39, 50, 65, 75 are the memory locations. Okay. Now if you see the second person data, it is stored at 39th memory location and the value of the particular that person is 14. And if you see the third person data, it is stored at the 50th memory location. If you see fourth person data, it is stored at 65th memory location. Because you don't have sufficient memory in the computer contiguously. You have memory, but it's not present at the contiguous locations. So how it forms a data structure is, wherever the space is available, it goes and stores the data, and along with that what it will do is it will store the address of the next location. Now if you see, this is the data. Okay, first student roll number is 10. Now what is the second student roll number? It will see the memory address here. So linked list like how linked list looks is, along with the data it stores the memory address of the next student. In an array you need not store it, because if you know the first person memory address, automatically let's say the first person memory address is 0. What would be the memory address of the 10th person? Okay, 10th person, 10 plus how many bytes you will take for an integer? 2 bytes. 10 into 2, 20. If you take 0 plus 20, like how if you represent this, let's say integer takes 2 bytes. Now first student is at first location. Now how to calculate the memory location of the 10th student? What is the first student location? 1 plus how many students are there between first student and the 10th student? 10 minus 1, 9, into how many bytes each person takes? 2, right? Now it means 1 plus 9 into 2, 18, 19. So at 19th location, you will have 10th person detail, 10th student details. Let's say first student starts at 9th memory location. Then you have to store it here 9. Then it becomes 27. So in an array, you need not store the memory location of the next students. If you need not store, like if you know the first student memory location, automatically you can calculate the remaining students memory locations also, because array is contiguous data structure. But in linked list, since these are not contiguous, how you know the second student or the second index details? You need to have a memory address of that. So that is the reason why you have data. Along with the data, you need to store the memory address of the second student. If you see, 39 is the memory address of the second student, and here if you see, 50th is the memory address of the third student, and here 65 is the memory address of the fourth student, 75 is the memory of the last student. Now how you traverse is nothing but going through the items one by one. Now first I'll come to first student, okay, 10. Now I'll see what is the memory address, 39. Then I'll go here. If you then I'll go here. So I'll go from 39. Where is 39 present? I'll go to the 30th memory location. Okay. So what is the data present in 39th memory location? 14. Okay. My second student detail is 14. My second student roll number is 14. Now I'll see the next memory location. Okay, 50 is the next memory location. 50 is the next memory location, right? Is the next student location. What it does is it goes to the 50. Now after going to 50, it sees the roll number. 25th is the roll number. Okay. Now after this, it will search the next memory location. Okay, 65 is the next memory location. It will go to 65. At 65, what is the data present? 29. So it will take the data of the fourth student and it will see the next student's memory address. 75 is the memory address. It goes to 75th memory address. At 75th memory location, it has 38 data. Okay, 38 is the roll number of the fifth student. And then it will search for the next student. If you see here, you don't see any pointer memory address here. You see something as null. So if you see null, then what it means is you don't have any further students present. Now let's say if you don't have any further student present, now let's say you want to add a new student. What you can do is you can create a, like wherever you have memory available in the computer, you can just create one more node like this and you can just point it, you can just point it. So that is how linked list is stored in a computer memory. Yeah. Now if you come to stack, so even like if you think if you want a real world applications, storing students data content in the list is nothing but array and the linked list. Now let's come to the stack. So, like in a hotel, you will see a pile of plates, right? One like one on the other. You will have a bottom plate. On the bottom plate, you will have you place one more plate. Likewise, you pile up the plates. That is nothing but a stack, like piling up the plates. Even if you see the stack, you see here, right? You have first student. On top of first student, you store the second student. On top of second student, you store the third student details. On top of third, you store the fourth. This is nothing but a pile. Even if you see like in a fruit vendor, he will place apples one on like one over the other, right? Even that is nothing but a pile. So that is a stack data structure. If you talk about queue data structure, like you can see vast number of applications using queue data structure. You want to buy a ticket. Let's say you are in a railway station and you want to buy a ticket. You stand in a queue, right? Whoever comes first, they will get the ticket and they'll come out of the queue. And whoever comes last, they will be at the end of the queue. Even if you see the stack operations, like first you place a bottom plate. On top of the first plate, you place the third plate. Like let's say you got a new plate. What you will do? You will put the plate on top of the highest one. It's like you're pushing one plate over the other, pushing. Now let's say I want to remove it. Like, can you remove it randomly? Can I go and remove the second plate directly? No. If you do that, everything will break. So for the stack, you either push a plate or you pop the plate. Even if you want to take out the 30th student, what you have to do is you have to remove 40, 20, then you take 30 and then you can reinsert 20, 40 again. So it's like push and pop operations happens in the stack. If you go to the queue data structure, so it's like if you take the stack, it's like first in, last out. Whoever comes first, that is the last person getting out of the stack. Like 10 have inserted first, but he is the last person that comes out of the stack. So that's why it is like first in, last out, or last in, first out, LIFO order. But if you come to the queue data structure, whoever comes first, that is the person who comes out of first as well. So enqueuing and dequeuing, whenever a new person comes, you keep adding the persons at the end of the queue like this. Like let's say a new person comes to the queue, you keep adding him to the end of the queue. And let's say, and now you want to delete or you want to remove persons, what you will do? You will do it from the front end, not from the rear end, right? So here if you see, dequeuing operation happens. We will talk in detail the operations in each and every data structure in a separate playlist. We are just discussing the overview of these data structures. Here dequeuing operations happen. from the front end. So even you have so many real world examples, like you stand in your queue, get something. Even for the stack also, pile of plates like this. Now let's talk about tree data structure. Okay, so tree data structure is like, even if you take a real tree, you have usually you have a root main branch. From the main branch, you have so many branches that spreads in all directions, be it left, right, in all directions. From the other branch, it even gets spreaded. So let's consider this is the main root of the tree. From the root, you have got two more branches. From this branch, you got other branches, right? This is how a tree data structures looks like. Mainly, it will have a root node, basically. Like, let's say you consider this as a node. You have a root node, and each root will have children, parent-children relationship. You have a main root node, you have children, and the children will have other children as well. Okay, this is how data tree data structure looks like. And you can, the other non-linear data structure is graph, right? Yeah, just a second. Yeah, and the other linear, other non-linear structure, data structure is graph. So this is the graph data structure. It is a similar, like if you see tree and graph data structure, both are like a similar. Like if you see the graph data structure, it consists of vertices and edges. Okay, vertex and edges, like it will have few nodes, and those nodes are connected by edges. See, this 0 1 2 are the nodes, and these arrow marks are the edges. So graph consists of vertices and edges. The only difference between tree and a graph is, for a tree, you have a root node and it starts out from there. This is the parent, you have children from here. But in a graph data structure, you don't have any such starting point. You can consider three, you can start from 0, or you can start from 1, or you can start from 2. You can start from anything. But whereas in a tree, you have a specific root node. So that is one difference. And even if you see, there exists a single path. From, let's say I want to reach 24, you have to come from 1 to 24. You don't have cycles, basically. Let's say if I add one more line here, like if I add one more line, let's say I add a one more line here, one more line here. What happens is, you come from here, you go from here, then you come from here, like from 1 to 12, 12 to 24. You this is one way. One more way is, let's assume this is non-directional. Okay, let's assume it's you have another direction. Yeah, let's suppose, yeah, yeah, let's suppose I add this particular edge here. I add this particular edge. Now what happens is, now I want to reach from 1 to 24. One way is 1 to 12, 12 to 24. Now you have got another way, 1 to 12, 12 to 25, and 25 to 24. This is a graph data structure. So in a tree, you have a specific root node, but you don't have that in a graph. And even in a tree, you have a single path that exists between any nodes. Even if you want to traverse from 24 to 27, there is a single path that exists. But in the graph, you can have multiple. It need not be that every time you can have multiple paths, but there is a possibility that you can have multiple paths. Like from 1 to 24, you have two paths exist here. This is a graph data structure. But if you consider a tree data structure, you should remove it. Okay, so this is the basic differences between tree and data structure, but we will talk in detail when you specifically talk about these data structures. Okay, now since we have got an overview of array, linked list, stack, queue, tree and graph, if you see array, linked list, stack and queue, these are all stored in a single level. Like let's say, even if you have linked list, what you will see, you can join all together, all. When you join all, it forms a single line or single level. Even if you take array, let's say I join 1, 2, 3, 4, all forms a single line or a single level. Even linked list, it forms a single line, be it wherever they are present. But if you join all these student details, all forms a single line. Even if you come to stack and queue, all forms a single line, be it a vertical or horizontal, it forms a single line, right? It has a single level basically. It's not an any hierarchical order. You don't see any hierarchy like parent child relationship here. You either have you either talk about the previous node or the next node, or the top node or the below node, right? Or the front node or the rear node, all exist, all have a single level. But if you talk about a tree data structure, you don't have that. You have multiple levels. See, this is one level, and this 12 and 15 are at other level, 24, 25 are at a different level. Even if, when you see a graph data structure as well, 0 it is present at one level, and 1 and 2 are present at different levels. Your data is stored in a hierarchical order, and you have multiple levels present here. you which is more kind of a non-linear type. When you come to a linear data structures will have a single level, like how we have seen in array, linked list, stack and queue. But in tree data structure and graph data structure, you don't have a single level. You have multiple levels, and these data are structured in a hierarchical order. Those are organized in the hierarchical order, right? So that's where this non-linearity comes. So that's why we have categorized data structures into two types, linear and non-linear. In linear data structure, you have array, linked list, stack and queue. And in non-linear data structures, you have trees and graphs. Yeah, that's it. So in this video we spoke about the kind of data structures, right? In the coming videos we will dive deeper into each of these data structures, how it is stored in the memory, how you retrieve it, and what are the various kinds of operations that we can perform on these data structures, and the different algorithms you use to perform few operations. We will talk about each and everything in detail when you go into a separate playlist of these topics. Thank you.